Welcome back again to my YouTube channel. In today's video, I'm going to look at question 1 of Physics Practicals Alternative B. So if you're preparing for this forthcoming exam and this is your first time tuning, don't forget to subscribe to this channel and turn on notifications to get notified each time I post videos. Now, we are asked to provide so many apparatus, and you know WAEC, we don't normally use all the apparatus. So let me list out the apparatus we are asked to provide. I'm going to tell you the one I was able to come up with and the experiment they are going to see with the apparatus. So let's go. We are asked to provide the following apparatus: G clamp, mixer rule, spiral spring, return stand with clamp, set of masses, sellotape, and stopwatch. But from this diagram we have on the board, we are going to use just these few apparatus. So we are going to be using the G clamp, the meter rule, then we have what? The set of masses, we have sellotape, and we have what? Stopwatch. For this particular experiment, we are not going to use what? Spiral spring and return stand. Is that clear? But there is still another experiment that you can use with these two. Do you understand? But in that case, you might not use G clamp and meter rule. Do you understand? Okay, so let's look at what you have on the board so you can explain this very well. Now, looking at what we have on the board, this is a bench or even a table. Now, this is a meter rule. Okay, this is a G clamp. We have the set of masses that was labeled M. We have series of masses. We have 50, 100, 150, and so on and so forth. Okay, what you are going to do for you to perform this task, you are going to clamp one side of this meter rule at 10 centimeters so that the remaining 9 will be from here to here. Okay, now you are going to use a sellotape to hold this mass at this end, extreme end of the meter rule. That should be at 100. Do you understand? I think this question is 2005, so you can check it up. I'll put it on the screen. This is a 2005 WAEC. Okay, this is 2005 what? WAEC. I think that is where I get this question from. So you can look up there to see what they actually did. Now, if you look at it now, you can see that by the time you use this sellotape to hold the mass and fix it at this point, which is extreme end, which is 100 centimeters, right? You are going to displace it a little for it to have vertical oscillation. Then use of your stopwatch, you're going to check the time for 20 complete oscillation. They can give you 10, they can give you 20 for number of complete oscillation. So you must look at the question closely to know what they actually want you to perform. Alright, now that is what you are going to do. Then after taking time for complete 20 oscillation, you are going to do what? Replace the mass with another higher mass, probably 150 gram. Okay, to see what we have. After which you can replace it with 200 gram to take the time. So it means that our table of values will look like this. This is the mass. We are writing just the mass and getting the time for 20 complete oscillation. Okay, now this is the time. You get the period. You know that period T is equal to the time taken, which is there, divided by number of complete oscillation. If the question said that I should calculate the time for 20 complete oscillation, that becomes the word period. That means n is 20, but n can be 10 depending on what the question wants you to do. Then whatever thing you have to square your values. And remember, this is in 3 decimal places, which is x.xss, right? This experiment is under moment of a force, so you may be asked to find some questions under that. Okay, and when I started this procedure, I decided to use 50 gram first, even though I asked to provide 150 gram. But the reason is that they might twist the question. Okay, but I want you to know, as the mass is increasing, what actually happens to the time. So that's why I decided to do it like that, but they're all the same. If you understand the concept, you can be able to understand the concept you're going to see in your exam. Now, I want you to watch this video to the end so I can show you how to perform this experiment and also show you how to plot the graph in case you see something similar to it. With no further ado, let's get right into the practicals. Now, these are the set of masses we're asked to provide. Okay, this is a G clamp, this is a meter rule, and this is a stopwatch. Okay, so let's clamp it for you to see how we are going to do it. Do you understand? So let's go. All right, so you can see the G clamp. Okay, I was able to clamp it at 10 centimeters from this other end. All right, then the remaining, which is the free end, I just allow from that distance to this end where the mass is kept constant. is 90 centimeters, because I'm working exactly what they say in this question. I'm going to put it up on the screen so you can understand what I mean by that. So what I'm going to do now, with the help of my stopwatch, I'm going to do what? I'm going to displace it a little to have a vertical oscillation, and I'll calculate the time for 20 complete oscillation. Okay, so that's what I mean. So let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now from what I have 7.80. Okay, well, we use a mass of 50 gram. Remember, that is the smallest mass I have, so you have to take note of that. So let me repeat the experiment again. If I'm going to increase the mass by using 100 gram, let me see what I'm going to get. Do you understand? So this is how you are going to keep changing the masses to get the time for complete oscillation. Do you understand? So let me record what I have, then proceed again with the second mass, keeping it at constant, which is the end of the meter, which is at 100 centimeter mark. Hope you get it now. So let's do that. I replace 50 gram with 100 gram because I want to repeat the procedure. Now what I'm going to do is to displace it for it to oscillate vertically. Okay, so I can get the time for 20 complete oscillation, and also to compare if a higher mass was added, what happens to the time? Will time increase or will time decrease? This is what you are going to find out when you are writing your observation, so that your trend will be correct. Remember, in physics we mark trend. Okay, so let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, now look at what we have. We have can you see it now? We have on the screen, we have 9.5 seconds. Okay, so that means there was an increase. The first one was 7.2, I think so. No, the first one was 7.8. Okay, now this one is 9.5, so I'm going to record it. Okay, so I'm going to repeat this procedure by exchanging the masses until you get to the highest mass given to you. Then with it, you are going to plot a graph. Now I'm going to repeat the procedure by using 150 grams. So I'm going to add 150 gram here. I use sellotape and hold it together, okay, for me to get the time for 20 complete oscillation. So I'm going to complete the procedure and show you how to plot the graph. So let's go. But with this, you can be able to do the experiment, okay, if you understand the concept. Now I started with when mass was 50 grams and I see what I got. Now I continued, the masses were increasing 50. Now the time I have too was increasing. I started with 7.80 and I ended with 14.80. So you can see as the masses are increased, the time is going to increase as well. Do you understand? So what they mark is trend. What is the trend? As the masses increases, the time increases also. So you're going to get your complete mark. So for us to get the period, which is on this column, we're going to do what? We're going to say that period is time divided by number of complete oscillation. That is, period t is equals to what? T over what? N. Now if I have this as 7.80, I'm going to divide by 20 to get my period, right? So whatever thing I have, which is my period, I'm going to square it to get my period square. Do you understand? All right, so let me just do the first one. I have 7.80 divided by 20. Now this gives me 0.39. Okay, now this is 0.39. Because I want it to be in 3 decimal places, I'm just going to add what? 0. Okay, so by the time I square my answer, it's going to give me 0.1542. Now if this one here is up to 5, I'm going to approximate to the next number, but because it's less than 5, I'll just leave it at 0.152. I hope that is clear. Now with this method, I'm going to do for all of them and get their values of period. So let's go. Okay, I've completed the table by finding the period and the period square. So let's proceed to the graph plotting. We have to plot a graph of t square against m. That simply means that t square is going to be on the vertical axis, while m is going to be on the horizontal axis. So let's go. And after solving, we're going to get our slope and the intercept of the graph. Okay, so let's solve. Okay, now so you have this type of graph. Your own might be bigger than this in the exam, so but I want to put out how you can plot this particular graph. Now if you have to plot a graph of t square against m, that means t T square will be on the vertical, while M will be on the horizontal. Okay, so let's go. The first step is to draw your vertical and horizontal axis. Okay, so remember you're supposed to use pencil, but because of clarity's sake, I decided to use pen so I can see everything clearly. All right, we have done the first step by drawing our outline, vertical and horizontal. If the question says plot a graph of T square against M, that means the T must be on the what? Vertical axis, and the M will be on the horizontal axis. Okay, now the next step we are going to do is to choose a very good scale. How do you choose this very good scale? But you have to write the title of a graph. We can say a graph of T square against M, right? Okay, so which scale do you think you are going to use? Look at it. From my T square, I have 0.5, 0.4, 0.4, 0.4, 0.2, 0.2, 0.1. Okay, but if we assume that this zero does not exist, you're going to be having 1, 2, 2, 3, 4, 4, 5, right? So we're going to use like 2 cm to 0.1 unit on T square axis. Do you understand? Okay, so let's go. So this is what? 0.1, 0.2, 0.3, 0.4. We're going to label it to the end. So let's go. 5, 6. Okay, sorry, this is 6. This is 7, 8, 9, 1.0, have 1.1, right? Okay, so from here I have what? Because this mass ranges from 50, that is on the mass axis. I'm going to say 2 cm to 50 grams. Next one is what? 100, followed by 150, followed by 200. We have what? 250, 300. We have what? 350. We have 400, right? So now we are done with that. I'm going to write the scale for them. Very, very important. Say scale is equals to 2 cm to 0.1 unit on T square what? Axis. Okay, then 2 cm to 50 unit on M axis. So that is all. Doing this alone, you're going to score 1 mark for the scale, and also for the titling of the axis, 1 mark. So let's go. So let's start plotting. I have this as what? 0.45. Now remember, this 0.548, right? This 8 here is up to 5. I'm going to approximate to call it 0.55, right? So I'm plotting 0.55 as against 350. But look at what you have. Look at what you have. If from here to here is 0.1, what does 1 stand for? 1 stands for what? 0.01. So this is 0.01, 0.02, 0.03, 0.04, 0.05. Okay, now I'm saying in respect of these ones inside, because when you are plotting, you're going to use just this and this to plot. But for the sake of the table of value to be complete, you're going to do what? Make it to be in 3 decimal places. But that does not mean you're going to use it to plot your graph. Okay, so let's go. Now if this is 0.45, we're working with 45 now. So this is what? 0.50, 51, 52, 53, 54, right? Okay, at against 350 grams, that is the mass. So I'm going to look at it here. Their point of interception, their meeting point. Okay, so to be on a safe side, you can even use ruler, but make sure you don't sketch it. Just follow the line up and get you where you have 0.55. So this is 0.55, right? This is 50, this is 55. Now look at it, this is 0.50. Okay, 51, 52, 53, 54, 5 what? 5. Look at it. At against what? 350. So I have a dot here. Do you understand? Okay, so this is how they do it. And the next one is what? When t square is 0.46. This is 0.4. Where it's 46. This should be 41, 42, 43, 44, 45, 4 what? 6. At against 300. So let's go. Okay, so this is 46 at against what? 300. Okay, now this is how you can perform this experiment in no time. So you just have to place it the way I just explained to you and know what the small inside calibration means. Then after that you can proceed to plot the graph. All right, so you can see that we have our point fixed where it's supposed to be. So the next thing is to draw our line, which is the line of best fit. So let's go. You just have to look at the point you are going to use. Now we have 1, 2, 3, 4, 5, 6, 7. Okay, and we have 7 points. It's not all the points will enter, but you arrange in such a way that it will be evenly distributed, even the ones that don't enter the line. Now look at it now. I have how many points? I have 1, 2, 3 that enter the line. Okay, this can equally enter if I draw it well. Okay, now the ones that don't enter, where are they? I have to rearrange it. Now look at it. If I have to do it this way, I'm going to have 4 points that enter the line. So the remaining 3 will be on this other side. If I should draw this line now, it cannot be assumed to be line of best fit. So I'm going to rearrange my point again to have something like this. Now this can go. I have 1, 2, 3, right? So the remaining 2, where are they? We have 2 here, 2 here. It is evenly what? Distributed. So if I join this line, it is now called line of best fit. Now for drawing this line alone, I have 1 mark. Okay, so let's go. Now I have seen it now. So the next thing we are going to do is to find our slope. So let's choose the best point to get our slope. So let's go. Okay, make sure you draw a very large triangle and occupy 1/3 of this page. Okay, so now what I'm going to do is to extend it. Now this is change in m, which is measured in gram, while this is change in what? T square, which is measured in second square. You can extend it on this line, take it down. Then take this one to this side. You can see it now. Now this is my m1 and this is my what? m2. Why this is t square 1, why this is what? T square 2. Now we are done with our graph. If you do all of this I've said in this graph, you're going to score 6 marks just for plotting this graph the way it is. So now let's solve for slope. Our slope will be equal to change in t square over change in m, right? This is second square over grams. Okay, so this is the same thing as saying t square 2 minus t square 1 all over m2 minus m1. So let's put in the values. We have my m2 to be 0.52. Now this is 0.52 minus this is a 0.21. 0.21. Okay, divided by the change in m. I have m2 to be what? 355. We have 355 minus, while my m1 will be 80. So let me divide. So let me work it out. This gives me 0.31 divided by, I have 275. Okay, so let's divide. So it's going to give me 0.00113. Okay, now that is second square per gram. So my slope is equals to 0.00113. You can say per grams second square. Okay, this is my slope. Okay, now maybe asked to calculate the intercept I on the graph. The intercept is simply where the graph cuts the vertical here. So my intercept here is 0.11112. So the intercept I is equals to 0.12 second square. Now remember that the intercept is gotten from a part of the graph. It is part of the graph. You're going to, like what I'm just doing now, you're going to tick in that place where it touches the graph and write what? C. Okay, now if your question says what? I, you're going to write what? I. Okay, depending what you're asked to do. Now there are some likely questions that may can ask you under this. The precautions you took while performing this experiment. Number one precaution is that, remember, you perform this experiment yourself, you must personalize it. I ensured that the meter rule was firmly clamped. Okay, then the second precaution, I ensured there was no zero error before, or can say before the timing of the stopwatch. So this is part of the precaution that you should note by performing this experiment. Okay, now you should also ensure that you, in case you might be asked to repeat the procedure for having two different times, you can write that as part of your precautions. Okay, now this topic is under moment of a force, so you should likely going to see questions under moment of a force. You should define it and how to solve calculation under moment of a force, and when the body is said to be in stable equilibrium. I hope that is clear. Now if this video was able to help someone out there, please don't forget to subscribe to this channel and turn on notification, because you have a lot to gain. And lastly, do not forget to share so that others that are preparing for this same forthcoming exam can see it and learn from there. I will see you next time in the next one. Bye for now.